Have you ever struggled to recall a name, a place, or an event? Memory shapes our identities, guides our actions, and connects us to the past. Yet, memory is not a perfect recording device. It is a complex and dynamic process subject to errors, distortions, and forgetting. Imagine memory as a vast library filled with countless books, each representing a memory. Some books are easily accessible, their covers brightly colored, and their titles prominently displayed. These are the memories we recall effortlessly, the vivid experiences that have shaped our lives. However, other books are tucked away in dark corners, their pages yellowed with time and their titles obscured by dust. These are the memories that elude us, the forgotten fragments of our past. The study of memory has captivated scientists and philosophers for centuries. From ancient philosophers to modern neuroscientists, the quest to understand how we remember and why we forget has yielded remarkable insights. Memory formation begins with encoding, the process of transforming sensory information into a neural code that can be stored in the brain. When we encounter something new, our senses gather information about the experience. This sensory input is then relayed to the brain, where it is processed and transformed into a memory trace. Imagine you are meeting a new person for the first time. As you listen to their name, observe their appearance and shake their hand, your brain is busy encoding this information. The more attention we pay to an experience, the more likely it is to be encoded as a memory. Encoding involves different levels of processing, from shallow to deep. Deep processing involves elaborating on the meaning of information, relating it to existing knowledge, and forming associations. The hippocampus, a seahorse-shaped structure located deep within the brain, plays a crucial role in encoding new memories. Once a memory is encoded, it must be stored in the brain for later retrieval. Memory storage is not a static process like filing away a document in a cabinet. Instead, memories are dynamic and constantly evolving, influenced by subsequent experiences and the passage of time. The brain stores memories in a distributed network of neurons, the specialized cells that transmit information throughout the nervous system. When we experience something new, connections between neurons are strengthened or weakened, altering the flow of electrical and chemical signals in the brain. These changes in synaptic strength form the neural basis of memory. Scientists believe that different types of memories are stored in different brain regions. Explicit memories are thought to be stored in the cortex, while implicit memories are stored in structures such as the cerebellum and the basal ganglia. Memory consolidation, the process by which memories become more stable over time, is essential for long-term storage. Retrieval is the process of accessing stored memories and bringing them into conscious awareness. When we try to remember something, our brains engage in a complex search process, activating neural networks associated with the target memory. The ease with which we can retrieve a memory depends on several factors, including the strength of the memory trace, the cues that are present at the time of retrieval, and our emotional state. Imagine you're trying to recall the name of a restaurant you visited last month. You might try to remember the location, the ambience, or the dishes you ordered. These cues can act as retrieval cues, triggering the activation of related neural networks and increasing the likelihood of recalling the restaurant's name. Retrieval is not always accurate, however. Our memories are reconstructive, meaning that we piece together fragments of information from different sources to create a coherent narrative. Forgetting, the inability to retrieve previously stored information, is a common experience that can be both frustrating and intriguing. While we may perceive forgetting as a failure of our memory system, it is actually a natural and adaptive process that serves several important functions. One theory of forgetting is decay theory, which suggests that memories fade over time due to the gradual weakening of synaptic connections, just as a path in the woods becomes overgrown and less distinct without regular use. Neural pathways associated with memories may weaken if they are not reactivated regularly. Another theory is interference theory, which proposes that forgetting occurs when memories compete with each other. This competition can occur in two ways: proactive interference, where Old memories interfere with the retrieval of new memories, and retroactive interference, where new memories interfere with the retrieval of old memories. For example, if you learn a new language, you may find it difficult to recall vocabulary from a language you learned previously. This is an example of retroactive interference. In addition to decay and interference, other factors that can contribute to forgetting include lack of attention, stress and trauma, and brain injury or disease. Conditions such as Alzheimer's disease, stroke, and traumatic brain injury can cause significant memory loss. While forgetting is an inevitable part of life, there are strategies we can use to enhance our memory and improve our ability to recall information. Here are a few evidence-based tips. Pay attention. Focus your attention on the information you want to remember. Avoid distractions and try to engage with the material in a meaningful way. Use elaborative rehearsal. Instead of simply repeating information rotely, try to elaborate on its meaning, relate it to existing knowledge, and form associations. Organize information. Organize information into meaningful chunks or categories. This can make it easier to encode and retrieve later. Space out your learning. Distribute your study sessions over time instead of cramming all at once. This allows for better consolidation and reduces interference. Get enough sleep. Sleep plays a crucial role in memory consolidation. Aim for 7 to 8 hours of quality sleep each night. Stay physically and mentally active. Exercise and cognitive stimulation have been shown to benefit memory. By incorporating these strategies into your daily routine, you can enhance your memory and improve your ability to recall information. Remember, the key to a better memory lies in understanding how it works and applying these techniques consistently. Memory, the ability to retain and recall information, is an extraordinary gift that allows us to navigate the world, form relationships, and build a sense of self. Yet despite centuries of scientific inquiry, memory remains an enduring mystery, full of complexities and paradoxes. We've explored the intricate processes of encoding, storage, and retrieval, uncovering the remarkable capacity of the human brain to retain vast amounts of information. We have also delved into the reasons why we forget, examining the factors that contribute to the fragility of memory. Despite its imperfections, memory is an integral part of what makes us human. It shapes our identities, connects us to the past, and allows us to imagine the future. As we continue to unravel the mysteries of memory, we gain a deeper appreciation for the complexities of our own minds and the extraordinary power of this elusive faculty. As we conclude our exploration of memory, one question lingers. If memories are constantly evolving and being reconstructed, can we ever truly know the past with complete accuracy?